Today, we'll be talking about partial derivatives. Let us start first with this first example, y equals x cubed minus xz squared plus 3z squared. Now, in normal operation of derivatives, you would take the derivative of everything of this, but in partial derivatives, we will take the derivative of each variable separately. We have two variables here, which is x and z. And so let us take the derivative of y first with respect to x. And so, by taking of this, we'll just focus on x and treat other variables as constant. So, in this case, z here is a constant or any number. Let's start with this first. The derivative of x cubed, this would be 3x squared. The derivative of xz squared with respect to x. As I said earlier, we will treat z as a constant. So what you're going to do here, let me just make this a visual lesson first. This would be xz squared. If you treat z here as a constant, let's put any other constant, any number. Let's take 3. So if we multiply this would be 9x basically. And so if we take the derivative of 9x, we would left with 9, which is the constant basically. And so by taking the derivative of this, x here would disappear, so you are left with z squared plus for 3z squared. If you replace z with a constant, let's say this would be 2 now. 2 squared would be 4. Multiply it by 3. You would have a number of 12. And since 12 here is a constant, the derivative of any constant here is 0. And so this would be the partial derivative with respect to x. Let's now focus on derivative of y with respect to z. So, focusing on this first, x cubed. As I said earlier, if we are focusing now here on z variable, and so let x here be a constant. So in x cubed, if x here is a constant, let's say number 1, because 1 is a constant, any number, 1 cube. 1 cube would be equal to simply 1, and the derivative of a constant is 0. So let's move on in here. The derivative of xz squared with respect to z. If we put x here as a constant, let's say it is 3. And so you're left with z squared. So what you're going to do here is to take the derivative. Derivative of 3z squared would be 6z. This is the derivative. And so by visualizing this, 6 here is the constant, which is x. Z here is the z right here. So this would be 2 multiplied by xz. Because this is basically 2 multiplied by 3z because of the 2 right there. So let's focus on here now, 3z squared. Since there is no other variable, just take the derivative of this normally, which is 6z. So the final answer here would be negative 2xz plus 6z. Let's start with the next example. U equal cosine of xy. So we have two variables here, which is x and y. So let's take first the derivative of u with respect to x. The derivative of cosine xy, the derivative of this first would be negative sine of xy, and multiply this by its inner function xy. And since we are taking the derivative of this with respect to x, x and y. Since it is respect to x, treat y as a constant. So pick any constant such as 2. So you are left with here is 2x. Derivative of 2x is simply 2. You are left with a constant. The constant here is the y variable. So this is y. Simplifying this, you are left with negative y multiplied by sine of xy. So taking the derivative of u with respect to y, the derivative of cosine xy would be negative sine xy, and take the derivative of the inner function, which is also xy. Since we are taking the derivative with respect to y, treat x as a constant here. So take any constant such as 3, y. Take the derivative of 3y is simply 3. You are left with a constant, which is x. And so the final answer here would be negative x sine xy. Y equal x squared plus v squared all raised to the power of negative 1/2. So let us take the derivative of y with respect to x first. The derivative of x squared plus v squared raised to the power of negative 1/2. This is based on chain rule. Just treat this as like a to the power of negative 1/2, wherein you will put first negative 1/2. So this would be negative 1/2 multiplied by x squared plus v squared, and subtract negative 1/2 by 1, which is negative 3 over 2, and multiply this by the derivative of the inner function, which is x squared plus v squared. So since we are taking the derivative with respect to x, treat v as a constant. So this would be equal to 0 automatically. And so just focus on x squared. Derivative of x squared would be 2x. Derivative of v, a constant, is 0. So simplify this, you are left with negative 2x divided by 2, or simply x multiplied by x squared plus v squared raised to the power of negative 3 over 2. Taking the derivative of y with respect to v, same thing, take first the derivative of this. So this would be negative 1/2 multiplied by x squared plus v squared raised to the power of negative 3 over 2, and multiply this by the inner function, x squared plus b squared. This time x here is a constant, so just focus on v squared. Derivative of this would be 2v. So this would be negative 2v over 2, or simply v, multiplied by x squared plus v squared raised to the power of negative 3 over 2. So this would be your answer. Y equal e to the power of negative 2xz. So let's take the partial derivative of y with respect to x first. Keep in mind the property of e to the power of u. The derivative of this would be e to the power of u multiplied by du, or the derivative of u. And so let u here be negative 2xz. And so we'll take the derivative of this with respect to x. So treat z as a constant here. So what we are left with here is negative 2z. So this would be eu, which is e to the power of negative 2xz. Multiply this by du, which is negative 2z. Simplify this, you would have negative 2z e to the power of negative 2xz. take the derivative of y with respect to z now. So this would be e to the power of negative 2xz. And so let u here be negative 2xz, derivative of u with respect to z. Treat x as a constant here. So what you're left with here is negative 2x. So this would be multiplied by negative 2x. Final answer would be negative 2x e to the power of negative 2x z. Z equal ln of x squared plus 3y squared. So let's take the derivative of z with respect to x. Keep in mind the property of ln. The derivative of ln of u would be equal to u prime over u. U prime or du, because it is basically the same. So let u here be x squared plus 3y squared. Derivative of u with respect to x. So treat y as a constant here. This would be simply 2x. Because y here is a constant, derivative of a constant. So this would be u prime or du, which is 2x over u, which is x squared plus 3y squared. So let's take the derivative of z with respect to y. Now, u here is the same, which is x squared plus 3y squared. Take the derivative of u with respect to y. So x here is a constant, so this would be 0. Derivative of 3y squared would be 6y. So this would be u prime, which is 6y, over u, which is x squared plus 3y squared. S equal to x plus 2y over x, all raised to the power of 2. So take the derivative of s with respect to x first. This is a quotient rule. The derivative of quotient rule, which is u over v, would be equal to v multiplied by derivative of u minus u multiplied by the derivative of v over v squared. So u here in this case, according to the formula, would be x plus 2y. V here would be x. So derivative of u with respect to x right here would be equal to simply 1. Derivative of v, which is x, is simply also 1. Now that we have our information, let's solve this. So first thing is to take the derivative of the outer function, which is the power of 2, which would be 2 multiplied by x plus 2y over x, and multiply this by the derivative of the inner function, which brings us to this one. So v right here would be equal to x multiplied by du, which is 1, minus u, which is x plus 2y, multiply this by dv, which is 1, over v squared, which is equal to x, which is x squared. X multiplied by 1 is simply x. X plus 2y multiplied by 1 is simply x plus 2y. And distribute negative onto this, so you are left with a is negative x minus 2y. X minus x is 0. So what you're left with here is negative 2y over x squared. So what you're left with here is 2 multiplied by x plus 2y multiplied by negative 2y over x multiplied by x squared, which is x cubed. So negative 2y multiplied by x is negative 2xy minus 2y multiplied by 2y is negative 4y. So this would be negative 2xy minus 4y. If we want to simplify this, let's factor it. Put negative 2 outside, so negative 2 multiplied by 2 would be negative 4 multiplied by xy plus 2y. So this would be negative 4 multiplied by xy plus 2y. So let us now move on with derivative of s with respect to y. So this would change. The derivative of u with respect to y. Put x as a constant, so you are left with here is derivative of 2y, which would be simply 2. Derivative of v, x here is a constant now, so derivative of any constant is 0. So take the derivative of the outer function first, which would be 2 multiplied by x plus 2y over x. Multiply this by the inner function, which would be v is x multiplied by du, which is 2, minus u here, which is x plus 2y multiplied by dv, which is 0. Anything that is multiplied to 0 is simply 0 over v squared, which is x squared. And so this would be 2 multiplied by x plus 2y multiplied by 2x over x cube, So distribute 2x amongst the parentheses. So this would be 2x squared plus 4xy over x cube. If you want to factor it even further and simplify, let's do it. So factor out 2x right here. So this would be 2x multiplied by 2 multiplied by x plus 4y over x cube. 2x multiplied by 2 is simply 4x. So this would be your final answer, 4x multiplied by x plus 4y. Over x cube.